Hi everyone, welcome back to my AP Calculus class. Today I'm gonna explain Riemann sum. There are four different types of Riemann sum: LRAM, RRAM, MRAM, and TAM. Today I just focus on LRAM, which means left rectangular approximation method. This is a method to find that area of under the curve with the x-axis between x equals a to x equals b using rectangular area. So I show you. So I start from a very simple function. So I usually use 3 steps to find the area under the curve. Our goal is to find under the curve of the graph of y equals x squared plus 1. So how we can draw x plus 1? That means y-intercept is 1 and then it's a parabola function graph. It looks like this, right? I want to find that x equals 0 to x equals 1. 0 to 1. So this point to this point. Our goal is to find what? Area between the graph of y equals x squared plus 1 and x-axis from x equals 0 to x equals 1. This is shaded regions area, right? To find that area, I'm going to use rectangles. Step 1, I will use 4 rectangles, and then I will use LRAM method. Okay, to make 4 rectangles, at first we have to sub 4 intervals, 4 identical subintervals with the same difference between them. So separate 4 different subintervals from 0 to 1, like this. So this first point is 1 over 4. The length between 0 and 1 is 1. 1 divided by 4, so 1 over 4. Second point is what? 2 over 4. 1/2. Third point, 3 over 4, 3/4. And then 1 is actually 4 over 4, right? 1 is 4 over 4. You can rewrite the 0, 0 over 4. That works, right? Okay. And then we draw vertical line at each x. So we can make 4 sub-intervals, right? So L means the left side, left. R means rectangular. A means approximation method. So we use the left side point, left end point of each sub-interval. So what is the left side point for the first subsection? 0 to 1/4. 0 is in the left, right? 0 is in the left. So we use left side, which means on the graph, 0, 1, this point. And then at the left side, left point, on the graph, make rectangles. Something looks like this. This rectangle, right? And then for the second interval, from 1/4 to 2/4, use the left end point, left side point, which is 1/4. So at 1/4 on the graph, this point, right? Make rectangles like this. And then left side points of third section, which means between 2/4 to 3/4, which is 2/4, right? At left side point, make rectangles. Last subinterval from 3 over 4 to 1, left side point is 3 over 4. At 3 over 4 on the graph, make rectangles. Okay, I'll do just step 1 now. Step 1 is what? Find these 4 rectangles area. First rectangles area, what is the length? The length is 1 over 4. 0 to 1 over 4. That's 1 over 4, right? That's length. So first equation, for the rectangle area, 1 over 4 times height. Height is this. That's 1, right? The 1 means y value when x equals 0. Y-intercept is 1. That is first rectangle's height. Okay, how did you get 1 actually in this function, using this function equation? Then 1 means y value when x equals 0. 0 is 0 over 4. So I use like this. 0 over 4 square plus 1. This is y value, okay, when x equals 0. It's the first rectangle area, right? What is the second rectangle area? Second rectangle area is this. Second rectangle is this. What is the length? 1 over 4. Okay, it's 1 over 4. 1 over 4 to 2 over 4. The length is 1 over 4. So 1 over 4 times height. Now height is not 1 anymore. Height is this point, y value. This point left and the point y value. So when x equals 1 over 4, y value is height. This is a height of second rectangle, right? So plug in 1 over 4 for x. So 1 over 4 squared plus 1. Okay, let's go to the third rectangle area now. The length is still 1 over 4. That height is y value when x equals 2 over 4. Because we're using left end point of each subinterval. So 2 over 4, plug in 2 over 4 for x, and then find the y value, 2 over 4 squared plus 1. The last rectangle area, this is the last rectangle, okay? Then last rectangle, what is the length? 1 over 4, what is the height? Y value when x equals 3 over 4. This length is height of last rectangles. So plug in 3 over 4 for x. Enter this function equation. So 3 over 4 squared plus 1. If we add all these 4 rectangles area, there's approximation value using LRAM with 4 subintervals, with 4 rectangles area, right? Just to try to add all these 4. 1 over 4, 1 over 4, 1 over 4, 1 over 4. This is a common factor of all these 4. So I will take out 1 over 4 times, what is left? 0 over 4 square plus 1. 1 over 4 square plus 1. 2 over 4 square plus 1. 3 over 4 square plus 1. So I'm going to do this. 0 square plus 1 square plus 2 square plus 3 square all over 16, 4 square. And then plus 4. Because 1, 2, 3, 4 ones there. That makes sense, right? And then calculate this. 1 over 4 times 0 squared is 0. Is 1 plus 4, 5. 5 plus 9, 14. So that is 14 over 16. So 14 over 16, which is 7 over 8. So 7 over 8 plus 4. This is equal to 1 over 4 times 40 is 32 over 8, so 39 over 8. 7 plus 32, 39. 39 over 8. So the sum of these 4 rectangles area is 39 over 4 times 8, 32. 39 over 32. It is about 1.2 something, right? I'm not sure. I have not calculator right now with me, but I can feel this number kind of 1.2. Okay, you can use your calculator to find the more exact numbers. Okay, first step is done. I just found 4 rectangles area using LRAM. My question is this: actual area we try to find is what? Area under the curve of x squared plus 1 with x-axis from 0 to 1, right? That area is actually this green color area. But we found just 4 rectangles area, right? Which one is bigger? Our number we got 1.2, that is smaller than actual area, right? Let the actual area is just A. That is what? A, compare A and 1.2. 1.2 should be smaller than actual area A. How much smaller? Like this much. This space, right? This much space smaller. So in this case, LRAM is less than actual area. Not always. So for the decreasing function, if we find the LRAM, that will be greater than actual area. But this function is an increasing function. That's why LRAM should be less than actual area. So we can say this 1.2, the area for rectangles using LRAM, that estimate is underestimated. Okay, it is underestimated. You understand why? Because it's smaller than actual area, right? Not always, but in this case, LRAM is underestimated. Okay, let's go to step 2. Today I'm using the same function y equals x squared plus 1 to explain 3 steps of LRAM method to find that area under the curve. Let's go to the next step. Step 2. Step 2 here. I will draw same function graph y equals x squared plus 1 here. 0 to 1. This is 1. I made 4 sub-intervals to make 4 rectangles, okay? But in this time, I'll try to find n rectangles. How many rectangles? N rectangles. That area possible in terms of n. What is n? I don't know. Yeah, n maybe 10, maybe 100. If you separate 0 to 1, n sub-intervals, what is the first one? First one, I don't know where it is, but first one, this rectangle left side point is still LRAM. Still, I'm using LRAM. So we have to use the left point. So this kind of rectangles, right? Left-handed point, something like that. Okay, what is this first x value? It is not 1 over 4 anymore. It's 1 over n. What about second rectangles? They point 2 over n. Keep going to n over n. 1 is n over n, right? So first rectangle's area is 1 over n times. Just still 1. How did you get 1? We plugged in 0 because 0 is the left point for the first section. That equation was y equals x squared plus 1, right? So plug in 0 over n for x. So 0 over n squared plus 1. Second equation, second rectangle's area. The length is not changing, always 1 over n, because we've made n in n sub-intervals, right? And then what is height? Height y value when x equals 1 over n. When you made 4 rectangles, right? The second rectangle's height was 1 over 4. X equals 1 over 4, and to find the y value. In this case, 1 over n, to find the y value. So 1 over n squared plus 1. Next, third one is 2 over n squared. You already got patterns, right? Keep going like this. What is the last rectangle's area? This point is n minus 1 over n, right? The last left side point was 3 over 4 if we made 4 rectangles. Okay, now n rectangles, the last point what? left side. Point is n minus 1 over n. So 1 over n times m minus 1 over n squared plus 1. And then you're going to add all these n rectangles area. Okay, so what is a common factor? 1 over n. Every single rectangle's area has same length. 1 over n times 0 square, 1 square, 2 square, until n minus 1 square. So 1 square, 0 square is 0, it doesn't matter. So 1 square plus 2 square plus, keep going to n minus 1 square all over the bottom was n, so n square plus how many ones? 1, 2, 3, 4, 5, n ones there. So n times 1 is n. Something like this, right? Got it? So I'm going to distribute property by n minus 1 minus n. And then we'll get 1 square plus 2 square plus, keep going to n minus 1 square over n times n squared, that's n cubed. And then 1 over n times n is plus 1. This is kind of answer, right? But it's not done. We have to find this numerator part. Using what? Using sigma formula. So today I give you 4 sigma formula, okay? It is very important for this part. Sigma k equals 1 to n. C is constant. That is just c times n. That's common sense, right? The first one is c plus case 2, c. If case 3, still c. C plus c plus c plus n times cn. And the second equation, sigma k equals 1 to nk. What does it mean? Plug in 1 for k, that's 1. Start from 1 to n, so next number is 2. Sigma means sum, so 1 plus 2 plus, keep adding to n, and then that formula is what? N times n plus 1 over 2. What is sigma formula? Sigma k equals 1 to nk square, which means 1 square plus 2 square plus until n square, right? That formula is n times n plus 1 times 2n plus 1 all over 6. Okay. Last one we have to know today is sigma k equals 1 to n k cubed. That means 1 cubed plus 2 cubed. Keep adding to n cubed. This is equal to n times n plus 1 over 2. It's just same as sigma k. Looks like that, but the whole thing is square. It's not the same thing. Okay, so look at this. Look at this part only, okay? Look at this part only. This part looks like this formula, right? But one thing is different. Is k equals 1 to n, but this k is from 1 to n minus 1. It's not n. Last term is n minus 1. So sigma, okay, we write here, better way, sigma k equals 1 to n minus 1 k square. Okay, that's why we use n minus 1 instead of n. So the original formula n times n plus 1 times 2n plus 1 over 6, plug in n minus 1 for each n in that formula. So n minus 1 times, next one, n plus 1, right? n minus 1 plus 1, that's just n. And then plug in n minus 1, the last term here. 2 times n minus 1 plus 1, so 2n minus 1 all over 6. Okay, so this part is actually n minus 1 times n times 2n minus 1 all over 6. So what is the final answer? What is the n rectangles area using LRAM? Sum of all n rectangles in terms of n. It's this, n minus 1 times n times 2n minus 1 over 6 over n cube, so over 6n cube plus 1. This is the final answer. This is the n rectangles area using LRAM. Okay, still, it should be underestimated. Even though we make 100 rectangles, some of that 100 rectangles area is less than actual area. Because the graph is increasing, and then we use the left point of each section, that's why. Okay, let's go to step 3. Okay, step 3. Now, step 3. We've just found the n rectangles area, which was n minus 1, n, 2n minus 1 all over 6n cubed plus 1. That was n rectangles area, right? Now I want to try. What about if we find the infinite many rectangles area? Just put limit and approach infinity on this. That means it's going to be the sum of infinite rectangles area. Very simple, right? And then just you can use the limit. You learned the limit already. If you expand this part, it's going to be 2n cubed plus something over 6n cubed, and then plus 1. Plus 1 is just 1. There is 1 doesn't increase any ends. And infinity, this part is infinity over infinity form. And then they have same degrees. So how did you solve that problem? That was leading coefficient towards the answer, right? So what is the leading coefficient of numerator? 2 denominators, 6 plus 1. That is 1/3 plus 1, which is 4 over 3. 4 over 3. This is what? Area of infinite number of rectangles. That infinite number of rectangles area exactly equal to actual area A. That is equal to actual area finally. So I just introduced how to find under the curve with the x-axis using LRAM. We found 4 rectangles area and n rectangles area, and I just used the limit to find the infinite number of rectangles area. Final answer should be exactly equal to actual area under the curve with the x-axis. That is LRAM. It's awesome, right? So I'm done today. Next video, I'm going to explain LRAM. That will be easier because you already understood. Okay, LRAM, but it's going to be easier. I'm done today. Thank you so much for watching my video. And then please click subscribe and like and turn on the notification. Okay, bye-bye.